Good evening, welcome to DIY Buddy Guy. In this video I'm going to show you how to figure out why your fan was not working. They're all constructed pretty much the same and in this case there are two independent fan motors and neither one of them is working. So check the obvious things, make sure that the plug they're plugged into has power. It did. And then you'll see, you may have seen plugs like these. There are fuses built into the plug itself. So next step is want to make sure that that's good. The tools that I've used on this project are number one Phillips screwdriver and a multimeter. And I have the meter set to continuity, the horseshoe shaped thing, which is ohms. And I also have it set so that when there is continuity, you'll hear the tone of the meter. I don't know if you can hear it in the background or not. When you touch the leads, the meter will beep, and you'll see it registers as almost no ohms, but it should be 0 ohms, no resistance. So that means there is continuity when you touch the leads. Okay, so the way to test that fuse is you can put one pin in the hole here on the plug, just for the sake of convenience while holding the camera here, and then the other pin, you can touch both sides of the fuse just to confirm. So it shows there's continuity across that fuse in one side. Let's check the back side. So there's continuity across the fuse, so that's saying that there is power at least going up the cord into the fan. So looking at the circuitry in the fan, you have two wires coming in. One is your power, the other one is your neutral, and it goes to the switch. So you only need to control the power. And the way that this fan is set up, the blue may be your low speed, for example, the red might be your high speed, and the black wire is your neutral. And you can see that the black wires are tied together here to the cord, the appliance cord. The reds are tied together, and then you have at one fan motor a red, a black, and a blue wire. So there's 3 wires. Now each one of these fan motors also have thermal fuses built into them, meaning that when they're running and for some reason if like they get super dusty and gummed up and they don't spin, they overheat, the thermal fuse in the windings will open. And almost every fan motor has that thermal fuse. And the way to tell if it does is again using the multimeter. So the way a motor is set up is, say for example this one has a neutral, which is your common, and then you have low speed power input and high speed power input. Both of those power inputs have to go to a common place, which is your neutral. So if I take my meter, the lead for my meter, and I put it on the black wire, which is the common or the neutral, and then I take the other one and touch either the blue or the red, your low speed windings or your high speed windings. If the windings are good, if there's no break in the windings, you'll have continuity. And I'll show you how I test that in just a second. So what I've done is I've taken the black meter lead, it doesn't really matter the color for continuity, and I stuffed it in the wire nut for the commons, your neutral. So that's one side of the circuit. And then I tested, stuck the other pin in the blue side, which would probably be the low speed, and this meter says that there's an open line. So when I move this out of this wire nut and stuff it into this wire nut to make sure that it made good contact with the metal grommet in there, it's the same thing. It says open lead. But something interesting, when I test from the red to the blue, it shows that there's continuity, which means that the windings where your low speed windings go to your common and your high speed windings go to your common, both of them come together at the common point on one side of that thermal fuse. So the meter is telling me that the windings are good up until the thermal fuse, and the thermal fuse, or there's something not allowing electricity to flow into the common. So what I did was I took apart this side here, and show you what the inside of the motor looks like. I'm not going to use this in my house anymore, but just for demonstration purposes. So I unwrapped this here, and assuming the red is your high speed, there it is right here. The blue will be your low speed, and both of these wires go into the windings, and then both of the windings come and they terminate here at the neutral. But you see this little square? See if I get a focus on that. That little square box right there is your thermal fuse. So if I leave one of my leads there, right, test my meter, I can touch one side of this and there'll be nothing. Well, that's the side that's on the input side. So if I touch this side, which is on the common side, there's nothing. But if I touch the other side that's on the windings, now I have continuity. So which means is that when I test across here on this thermal fuse, it's telling me that there's a break in this thermal fuse and that it's open. So what I'm going to do real quick for demonstration purposes is I'm going to show you how to confirm that that's actually the case. So I peeled back the rubber insulators that's on the legs of this thermal fuse, and when you twist the wires together so that both legs of that thermal fuse touch, it closes the circuit. So now, let me shut the meter here. So now essentially the fan motor is repaired, because instead of this part being authentically in good condition where it has a measure of protection against a thermal overload or from fire, we're bypassed it, closing the circuit, essentially removing the safety feature, which is bad. So I'm not going to use this in my house anymore. However, you could replace this part and solder in a new thermal fuse and protector, and the fan would work. And one quick way to verify that this is now functioning is to use the power cord, and I'll show you how. Hold on a second. So if, for example, you had a good fan motor that you knew was functional and operational, in this case we have a bypass safety, making it, for the sake of the video, quote, good, and it's not. If we touch one lead, one meter pin to one side of the plug and the other meter pin to the other side of the plug, we go from having an open line to continuity through the entire circuit, from one side of the plug through the entire fan motor, the switch, and back out through the neutral. So if a fan motor is bad, if there's a break in the windings, you won't have continuity and the circuit's not complete. So this is the inner workings of a fan, it's a thermal safety. Now the question in my mind is, why did both of them go bad at the same time? Because I put the fan in the window, turned it on, went to work, I came home, it was not working, and tearing it apart, my meter is telling me that that thermal fuse is the problem on both fan motors. The diagnosis is the same. So I am not going to use this anymore. It's more practical for me, rather than buying a new thermal fuse, to just buy a new window fan. But that is how you diagnose and troubleshoot any fan motor in particular. Thanks again for watching.